It's about 2:45. Should we get started or should we wait a few more minutes?
Let's do it. Let's get started. People can trickle in.
Okay, sounds great. All right. So welcome to the WiDS Puget Sound 2020 Conference Workshop Track A. Up next, we have Emily Miller, a data scientist for DrivenData, and she's going to be presenting actionable ethics for data scientists. Emily, if you're setting a timer, just a reminder to start your timer. Enjoy.
Great, and welcome everybody. Thanks for joining today's workshop on actionable ethics for data scientists. So as Kristen said, I'm Emily Miller. I'm a data scientist at DrivenData. And to give you just a little bit of background, DrivenData is a data science and machine learning consultancy in the social good space. And so what this means is that we work with nonprofits, NGOs, governments, and socially minded private sector companies to help them leverage the kind of power of machine learning to really maximize their impact. And we do this primarily through direct client engagements, as well as through hosting online machine learning competitions in the social good space. So if you find yourself with some extra time right now and you want to try to win some prizes or just build your skills on some meaningful data sets, I encourage you to check out drivendata.org and see some of our current competitions. We launched one not too long ago about predicting flu vaccination rates, looking back at the swine flu from sociodemographic characteristics. So very timely and a cool data set to be working with. Apart from our direct client engagements and competition work, we also devote some time to developing open source projects. And these are really a way for us to give back to the data science community. So today we're going to be talking about one such tool on data ethics. So let's talk about our plan for today. We have an hour. So the first half is going to be more of a talk portion, and I'm going to be talking through what an actionable approach to data ethics looks like. And for this, we're going to be using Dion, which is a tool that we built at DrivenData, which lets you easily add an ethics checklist to your data science projects. So I'm going to give you a bit of background on why this is structured as a checklist and some of our perspectives in building this, but we're going to focus primarily on the checklist content itself. And so this checklist is not going to tell you to remove variable X from your model. It's not going to give you simple answers, but it's going to help you ask the questions that can surface the different ethical considerations that are at play over the course of the data science process. As I go through this, I'm going to be rooting this in concrete examples of times when things have gone wrong, as this can be a really helpful way to get a more concrete view of some of the concepts on the checklist, and also understand where in the process having this sort of ethical discussion might have helped provide a course correction. After that, we're going to be taking just a little bit of time for some Q&A. Feel free to submit your questions throughout. You can use the chat icon, and my colleague Christine is going to be monitoring the chat, responding to that, and then batching up some of the questions so that we can discuss them. In the second half, we're going to get more hands-on, we're going to get interactive, and we're going to work through a mock case study. And so I'm going to divide you up into small groups using the breakout room functionality in Zoom so we can actually talk to each other. And we're going to practice working through the ethics checklist based on a scenario that I give you so we can start to understand what is it like to have these conversations, to think about the trade-offs, the nuances, and think about what that way forward might look like. So let's dive in. Ethics. So we're not going to get too deep into philosophy today. We're just going to take the dictionary definition here, which is the moral principles that govern a person's behavior or the conducting of an activity. And so when we think about ethics, we have to remember that ethics is hard, right? Trade-offs are inevitable, and as economists like to say, there's no free lunch. Additionally, it's important to remember, especially as we're taking this back to our teams, that reasonable people can disagree, right? There's oftentimes not one right answer. We have to weigh the trade-offs and come up with our way forward, but ex ante, it's not clear that there's only one right path. Thirdly, and if you take away only one thing from the talk, let it be this, and that's that good intentions are not enough, right? We must intentionally consider the consequences of our choices. So in short, I'm not going to tell you what the right answer is or exactly what you should do, but I am going to give you a practical starting point for incorporating ethics into your data science work. So I wanted to just take a quick step back and say, why does data ethics matter? right? So we all know that data is important, and there's no shortage of articles telling us this, right? We've seen data be called the world's most valuable resource, and we all know that data scientist is the sexiest job of the 21st century. So what we have to remember is that, right, we see data impacting industries across the board, right? We know that it's impacting healthcare and criminal justice reform, among many other industries. And what we have to think about is that as the use of data becomes more widespread, so do the impacts of how the data is handled and how the algorithms are designed. And so we've already seen cases, right, where things have gone awry, right? Well-intentioned algorithms have perpetuated biases and systemic inequalities. And so I think it's fair to say that we can agree that it's increasingly important to integrate ethics into data science, machine learning, and AI. But a lot of conversations about ethics can be rather theoretical, and they can talk about how ethics is important, but not necessarily help practitioners understand how to deal with this in a day-to-day way. So the question that we started with was really, how can we help data scientists engage with ethics in an actionable and a practical way? And so for this, we built Dion. What is Dion? Dion is an open source command line tool that lets you easily add an ethics checklist to your data science projects. You can read a lot more about this on dion.drivendata.org. That's going to contain a lot of the content that I'm talking through today, and so it's a great reference for the future. But let's unpack this a little bit more. So first, why an ethics checklist? And here I want to call out that we were really inspired by previous work, a lot of great work thinking about why checklists are helpful, in particular some work called Of Oaths and Checklists. And this kind of gave us the framework for thinking about why a checklist is helpful here. So a few things drawn from that is that checklists are really good at connecting principles to practice, right? They help us translate these big picture ideas into smaller everyday tasks. Checklists are also designed to be actionable. They're specific, they're focused on execution, and they're used repeatedly, right? This is in contrast with oaths that can be quite vague, such as do no harm. Finally, checklists help ensure that we don't overlook important work, right? Checklists serve as reminders, and they help embed these considerations into our workflow so that these discussions happen even in fast-paced environments. So by now you might think, okay, a checklist sounds helpful, but why did you make it into a Python package, right? Why didn't you just write a Word document and leave it at that? So the reason why we put this into a Python package and had this become a command line tool is that we really wanted to keep data scientists in their everyday workflow, right? We wanted to keep data scientists working at the terminal in text editors in Jupyter notebooks. And so this makes it really easy to work with Dion. In addition, it allows the checklist to be scriptable, right? So you can put it in your bash RC or your makefile. It's customizable, so it's really easy to pass in a custom checklist. If you have a specific set of concerns that are really domain specific, you can include that. And so taken together, at the start of a project, we can easily pip install Dion, output our checklist, submit a PR with that, and that's a great way to start the conversation with your team. Now the checklist is in GitHub, it's easy to comment on it, track changes, collaborate, make sure that you're thinking about this as you go throughout. One other option is you might just be doing a standalone analysis in a Jupyter notebook. We also support a variety of formats from Markdown to HTML to Jupyter notebooks, so you can also just append the checklist directly into your Jupyter notebook and engage with these considerations as you're going through the analysis itself. So it takes only 2 lines of code to run. It's really simple. You pip install it, and then you use dion-o, which just outputs the checklist to a file of your choosing, in this case, ethics.md. And that's going to give you a markdown file with all the checklist content. So I just want to share a few perspectives before we get into the checklist content itself. So our first is that our goal is not to be arbitrators of what ethical concerns merit inclusion. Right, this is meant as a sensible starting point to capture a set of concerns that we see as common across a number of different domains and data science processes. But we do believe that teams will benefit from building custom checklists, and as I said, we make it easy for you to do so. Second, checklist items are meant to provoke discussion. So you're going to notice that a lot of the checklist prompts are framed as, have we considered, have we tested, have we thought about? Right, the goal of the checklist is not to concretely recommend specific actions, but rather to help you consider and discuss the relative considerations that are at play. Thirdly, the decisions on the ethical courses of action are not up to data scientists alone, right? So the checklist is designed to provoke conversations around issues where data scientists have a particular responsibility and perspective, but we fully recognize that this should be happening within a broader organizational commitment to doing what is right. And finally, strictly statistical best practices are not included, right? This checklist is really meant to go above and beyond statistical correctness. So the checklist is broken down into 5 sections: data collection, data storage, analysis, modeling, and deployment. And this is because there are different ethical considerations that arise at different points in the data science process. And it also might be the case that your project might not deal with one of these sections. You might not be responsible for data collection. And so it's totally okay to have NA be a response to either individual items or maybe a section as a whole. So we're strong believers in the power of example. And so one of the things that we did when we put together all the documentation for Dion was put together a table of examples of times when things have gone wrong. And there's at least one example for every item on the checklist. And we found this to be just a really helpful way of making some of the concepts more concrete. And so as I go through the checklist content now, I'm going to give you an example from each section, and know that all of these, you can read more about the original sources for these on dion.drivendata.org, and you can read about other examples there as well. So let's dive into the checklist content itself. We're going to start with data collection. The first item here is informed consent. And this asks, if there are human subjects, have they given informed consent? And by this, we mean, have subjects affirmatively opted in with a clear understanding of the data uses to which they consent, right? This is really important to avoid exploitative relationships. The second item here is collection bias. Have we considered sources of bias that could be introduced during data collection and survey design and taken steps to mitigate those? So here we want to think about, right, what has happened in the process of collecting the data. And there's a lot in the statistical literature about designing a representative sample. And that's important, right? But even if we have a representative sample, we can still have bias in our data, because there are going to be things that we didn't capture, right? Or there might be biases that we've inadvertently introduced based on the survey design itself. So for example, if we ask people their gender and we only give them 2 options, male and female, then we've excluded the portion of the population that identifies as non-binary, right, and introduced that bias into our data. This becomes even more important and sometimes harder to spot in passively collected data, and I'm going to give you an example of that in a bit. Thirdly, we have limiting PII exposure. Have we considered ways to minimize the exposure of personally identifiable information, for example, through anonymization or not collecting information that isn't relevant for analysis? Right, so here we want to think about, what's the data that we actually need, right? If we don't need people's names, if we don't need people's email addresses, if we don't need people's real addresses, then don't collect that data, right? If you don't need it, if you're not going to use it, it just exposes you to additional risk, and it's better off just excluding it and thinking about that up front. So where have things gone wrong? So I want to give you an example right back on the collection bias, thinking about passively collected data. So this example comes from a smartphone app called Street Bump. And the idea here is that this app was going to passively detect potholes using your phone's accelerometer and GPS data, and then report these potholes to the city. And so on the surface, this sounds like a great idea, right? We're not going to bother people, but we're going to get data and we're going to make more data-driven resource allocation decisions. But we have to think about who owns a smartphone, right? And we know that elderly populations are often less likely to own a smartphone, and this can also be the case for lower income populations. And so if we use this to then direct public resources, we might actually divert resources away from areas with a larger elderly population or lower income population toward richer and younger areas. So here we end up with unfairly discriminatory results because of the bias in how we collected the data. Second, we have data storage. So the first item here is data security. Do we have a plan to protect and secure data? And by this, we're talking about things like encryption at rest and in transit, access controls on internal users and third parties, access logs, and up-to-date software, right? And this is going to come as a surprise to no one that data security is really important, and we want to make sure that we're thinking about it. The second item here is right to be forgotten. Do we have a mechanism through which an individual can request their personal information be removed? So this is particularly important in light of GDPR, which includes the right to erasure. And this allows an individual to have their personal data be deleted and to halt third parties' processing of their data. And so even if this isn't a legal requirement in the country that you're in, this is still really important to think through. And then finally, data retention plan. Is there a schedule or a plan to delete the data after it is no longer needed? So we want to think through, how long do we need the data, right? Is it the case that after 90 days of not using the data, we can remove it, right? We don't want to have old unused data lying around because that just exposes us to various data security and privacy breaches. So for the example here, I want to talk about Equifax. And some of you might already be familiar with this. For those who aren't, Equifax is a credit reporting agency. And so what this means is that if you take out a loan to, say, buy a house or buy a car, your bank is going to go to Equifax to assess your creditworthiness. And then this will determine if you get a loan and what those terms and conditions will be. And so because Equifax is in the business of assessing creditworthiness, they have a ton of PII. They have salary data, they have tax data, they have past addresses, social security numbers, driver's licenses, you name it, right? And so what happened back in 2017 is that hackers exploited a simple website vulnerability and stole the personal and financial data from more than 146 million people, which is a breach on record scale. Something that's interesting here in addition is that after the hackers exploited that initial vulnerability, they essentially gained the keys to the kingdom and were able to steal so much data, right? So despite having this vast amount of PII, Equifax didn't have effective multiple layers of control. So let's talk about the analysis bucket. Lots of good things in here. So the first one is missing perspectives. Have we sought to address blind spots in the analysis through engagement with relevant stakeholders? Right, such as checking assumptions and discussing implications with affected communities and subject matter experts. So this is really important for us at DrivenData because we work across a large number of domains, right? We do work in healthcare, we do work in financial inclusion, we do work in conservation work, and we're not experts in all of those areas, right? So it's really important as we go through our work, we're being aware of, you know, what don't we know, right? Are we defining things properly? Are we interpreting things properly, right? Are we making sure that the work has the impact that we intend? Secondly, we have data set bias. Have we examined the data for possible sources of bias and taken steps to mitigate or address these biases? So a few examples here are things like stereotype perpetuation, confirmation bias, imbalanced classes, or omitted confounding variables. And so the thing that we need to think through here is that no matter how much work we put into eliminating bias during data collection, our data set will always be biased. And so the question to ask is not, is my data set biased, but how is my data set biased? Right? And so we really want to spend time thinking through what are the potential sources of bias, because those are going to just propagate down our modeling work. And so we want to be aware of it here so that we can take steps to correct and address it. Thirdly, we have honest representation. Are our visualizations, summary statistics, and reports designed to honestly represent the underlying data? So I love a good data visualization. I think that they're really effective in communicating things. They're a lot more interesting to look at than just a table of numbers. But we have to remember that those who design data visualizations have a lot of power and a lot of responsibility, right? So we want to think through, are we, designing these in a way that truly represents the data? Are we only using one axis instead of two axes if we don't need to, right? Are we using color in an intuitive way so that it makes it easy for the user to get the accurate interpretation? Next, we have privacy and analysis. Have we ensured that data with PII are not used or displayed unless necessary for the analysis? So here we need to think through, as we're producing some of these outputs, is there any risk to exposing any sort of PII or private information? And so I'm going to give you an example of this in just a moment, which will make this a bit clearer. And finally, we have auditability. Is the process of generating the analysis well documented and reproducible if we discover issues in the future? So here we want to be thinking about, if we're working in Jupyter notebooks, can we restart and run all and get the same result, right? Is our process clear? Because one, that helps us make fewer errors in the first place, but it also makes it much easier to address issues if we find them later on. So where things have gone wrong here. So this example comes from Strava. And for those who aren't familiar, Strava is another smartphone app that lets you track your exercise routes. So it uses your phone's GPS, et cetera, to track how far you've gone, right? You can input your type of activity, if you've gone for a run or gone for a bike ride, and you can share this activity with friends. And so Strava decided to release a heat map of all the exercise routes of their users. And this was some, 3 trillion data points. And so it was intended as this really cool visualization. And what ended up happening is that in this visualization, they ended up revealing sensitive information on military bases and spy outposts, right? So much to security experts' horror, it turned out that the Strava users in certain areas like Syria and Djibouti and Afghanistan were almost exclusively foreign military personnel. And so what that meant is that the routes that they're taking are basically showing the outline of the bases. So it's not even just showing where the bases are, which is something that you can detect to some extent from satellite imagery, but it's actually showing the internal layout, right? Highly sensitive information has been released because of this cool visualization. So on to modeling. The first one here is proxy discrimination. Have we ensured that the model does not rely on variables or proxies for variables that are unfairly discriminatory? So we might not have variables on gender or race in our model, but if we have variables that are very correlated with those features, then their effects are going to be incorporated into our model. And so we need to think through not just how do we not include those variables, but are we actually picking up on those unfair effects? And if so, how do we want to mitigate that? We also want to think about fairness across groups. So this is, have we tested model results for fairness with respect to different affected groups? For example, testing for disparate error rates is a great way to do this, right? There are a number of metrics. There are toolkits out there. IBM is a fairness toolkit that talks about all the different fairness metrics, right? And so we want to think through, what do we mean by fair here? How do we measure it? And then make sure that we implement it. On metric selection, we want to think through, have we considered the effects of optimizing for our defined metrics and considered additional metrics, right? So this is thinking through, what is our metric prioritizing, right? What does a true positive look like? What does a false positive look like? What does a false negative look like? How do we want to weigh those, right? Is there something that we care about that's not incorporated into our current metric? And if so, then maybe we want to add an additional metric to make sure that that thing we care about is being prioritized by our model. Explainability. Can we explain in understandable terms a decision the model made in cases where a justification is needed? So explainability is becoming particularly important in healthcare, and I'm going to give you an example of that in a moment. So we need to think through, is this a case where explainability is really important? And if so, how does this affect our model choices? Finally, communicating bias. Have we communicated the shortcomings, the limitations, and the biases of the model to relevant stakeholders in ways that can be generally understood? So here we need to think through, right? We know that on the data science team, there are going to be these shoulda, woulda, couldas, right? If only we had more time, we would have done this, or, oh, this model does well here, but it doesn't do very well here, and here's this caveat, right? We need to make sure that we're communicating those, that our analysis can be understood in the context of its limitations. So to give you an example of where this has gone wrong, there were researchers who were doing a study. They were trying to predict the probability of death for patients with pneumonia. And the idea was to identify high-risk patients so that they could be admitted to the hospital for additional care, and so that low-risk patients could be sent home. So they trained a neural network, and when they were examining the results, they found a surprising finding, and that finding was that the model recommended that patients with asthma could be sent home, right? They identified them as low risk. And the subject matter experts knew that this was incorrect because they knew that patients with pneumonia who also have asthma have a very high risk of dying and are typically admitted directly to the ICU for intensive care. And so given the success of this intensive care, the neural networks had associated having asthma with having low risk, right? When they were actually just not picking up on that intervention. And so it was thanks to explanatory models, there's actually a logistic regression that this issue was identified and corrected, right? But this speaks to the importance of, especially in healthcare, especially where we're making life and death decisions, it's really important to understand why our model's making the decision that it's making so that we know whether we should be trusting that decision. And finally, deployment. So here we start with redress. Have we discussed with our organization a plan for a response if users are harmed by the results? So we want to think through with our team, what does this look like, right? How do we evaluate this? How do we evaluate these cases? If this does occur, how do we make adjustments to our model and make sure that we have a plan for that ex ante? Second, rollback. Is there a way to turn off or roll back the model in production if necessary? Right, so if we find that our model is causing harm, we need to make sure that we have a way to either turn this off or roll it back to an earlier version to prevent and stop future harm. Concept drift. So this asks, do we test and monitor for concept drift to ensure that the model remains fair over time? And so concept drift is basically, did the statistical properties of the target variable change in unforeseen ways? And I'm going to give you an example of this in a moment to make this a bit clearer. And finally, unintended use. Have we taken steps to identify and prevent unintended uses and abuses of the model? And do we have a plan to monitor for these once the model is deployed? So obviously we can't think about, we can't foresee all the ways that someone could misuse or abuse our model, but we do want to think about if there are some ways that we can directly address that, right? So there was a really powerful text generation model that the researchers didn't release in its entirety because they deemed it to be too dangerous to just put this into the public domain. And so they released a portion of it and withheld another portion. So that's a great way to think through what might go wrong and then, right, can we do a partial release as a way of preventing harm? So going back to concept drift, I want to talk about predictive policing. And some of you might be familiar with this concept, but for those who aren't, the idea here is to predict future crime using past crime data. And the thought is that in doing so, we can help have a more effective allocation of police officers so that they're in the areas where they're most needed. And then this can potentially deter additional crime. So the way that this works is that police officers are sent to certain neighborhoods based on historic crime data. But then the data that's fed back in the model is the data that's based on the crime that police officers find. And so we know that police officers, when they go to an area, tend to find some crime, which gets fed back into the model. But what happens is we lose any comparison of if there was more crime in the neighborhood that they went to versus if they would have gone elsewhere, right? And so what happens is that we get this feedback loop where the decision that the model makes directly affects the data that's fed into it going forward. And so the concept drift here is we've gone from having an initial historic true crime rate to a biased version of the observed crime rate that's a product of the model decisions that we're making. So that's the overview of the checklist content itself. I know that that was a lot to digest. The good news is we're going to spend the rest of this workshop working through this as a way to kind of help digest what this looks like and put it into practice. So before we do that, I just want to take a few minutes here to address any questions. I haven't seen any come through in the chat, so now's a great time. If you have questions, please drop them in. And if there are no questions, then we'll keep going and feel free to ask questions as we get into this. Wait another few seconds to let people finish typing. Great, people were typing. All right. First question, who was involved in creating the list? Was it a combination of data scientists as well as social scientists? Great question. So how did we develop this checklist, right? As we said, our goal is not to be arbitrators of what concerns merit inclusion. So the way that we did this is we looked at a lot of existing work by various organizations, some private sector, some civil sector, to look at what are these concerns that keep popping up, right? Either through lists of corporate principles or through Data for Democracy has some great work that we drew upon. That was a really big crowdsourced effort. And tried to kind of distill these down into like those overlapping areas, right? The set of concerns that we kept see coming up. And so then we framed it into questions that we thought would help be prompts, but really identifying what was on the list is based on existing research in this space. And so that's why we also encourage people to try it out, let us know how it goes. You can file issues on GitHub to modify the checklist if you think that there's a concern that's missing that should be included, or if you just have custom checklists that are helpful in your work, you can use those. Is the checklist customized based on the data analysis task that is being handled by a particular project? Great question. So I haven't run into a need yet to customize it based on a specific domain. There have been areas where that have not been relevant, right? Where I haven't been deploying a model, and so that section wasn't relevant. I do think that the concerns really capture kind of the broad brush of the sorts of issues, and then you get to think through within them, right? If you're looking at privacy and analysis, that's going to really depend on like what visualizations you're doing, what your analysis outputs are, what kind of PII you had to begin with. So a lot of those like nuances are captured in the discussions themselves rather than in changing the set of concerns that come up. Do I know what solutions were found to the observed versus true crime rate problem? Ooh, that's a tough one. So I don't know what the right solution is there with predictive policing. One thought I have is that this feels like the sort of thing where having additional data is critical, right? Where maybe you can have your model making some predictions, but you need some way of validating that. So maybe it makes sense to send a set of police officers to essentially a more random sample to try to get a better sense of what that true crime rate is. So you can track the difference between that kind of true rate and that divergence, right? It might be one way to start estimating a portion of the bias, but I'm not an expert on predictive policing. Any other questions? Great, so let's keep trucking along. I think that this interactive portion I think is going to be fun. It's just a helpful way to kind of roll up our sleeves. So ethics in practice, let's do it. So what we're going to do here is I'm going to give you a scenario. We're going to talk through kind of what your goal is. Imagine you had this kind of data. Imagine you were doing this kind of task. And then I'm going to break you up into groups to discuss it. So let's start out. First, our scenario. So imagine that you've been hired as a consultant by a major insurance company. And this insurance company has formed an agreement with Apple to get data from their HealthKit app. And they want to use this fitness data to reward or incentivize people who are very healthy by awarding them credits toward their health insurance premiums. So what data do you have? You've been given passively collected health data from iPhones, right? And this includes information on physical activity, so the type and the duration, right? Was it a run? How far did this person run? Their resting heart rate, their age, their gender, their height, their weight, and their location. So these are the variables that you're working with. And the data is received in monthly batches. So your initial data set is quite large. It contains 1 year of daily data for 1 million people. So lots of data to work with. So your task here is to design and deploy a model that identifies who should receive credits toward their health insurance. Carefully consider the ethical implications of your choices. So how does this work? So what I'm going to ask everybody to do, so you could pip install Dion if you've got your terminal up and running, but for now, what's going to be faster is just head over to the URL that's at the bottom of the screen, dion.drivendata.org /# data science ethics checklist. Right, this is going to bring up the default checklist that I went through. So I'm going to give everybody a few seconds to go open your browser and head to this URL. And this is what you're going to be working through. So I'm going to divide us into 2 groups. We've got about 25 people, so I have a little bit more than 10 people in a group. And what I want you to do is I want you to start going through individually these different items on the checklist, right? So you can start with data collection and think through, what did informed consent look like here, right? What are different concerns? Thanks to Lana for posting that in the chat. I appreciate that. Right, so I want you to start going through those items and saying, what are the different ethical considerations that come up? Like, what are the issues? How do I spot them? And then think through, what would I do in this scenario, right? So with this amount of data, what would that data storage look like, right? Or maybe you want to focus more on the analysis section. We only have about 15 or so minutes, and so I know you're not going to get through the entire checklist. That's okay. Feel free to jump to some of the ones that you think are more salient. So I encourage you to take some notes on some of these concerns that you see and how you plan to address them, because after this, after we go into our groups, I'm going to bring you all back together. We're going to have a share out and talk a bit about what everybody found. So I'm going to stop my share and I'm going to separate you into breakout groups. Oh, just one note before I do that. So I'm going to be dropping into one of the breakout groups. My colleague Christine is going to be dropping into the other one. And we're really just there to kind of listen in and see what are the concerns that are coming up. We're on hand to answer any questions, but we're not going to be guiding this exercise. We really want you guys to have this discussion and just think about us as kind of a fly on the wall. So I'm going to give you each about 15 minutes for this, and then I'll bring everybody back together. So I'm going to create the breakout rooms now.
Is there a way for us to still be able to see the prompt? I don't see it.
Great question. So I am going to be dropping the prompts in the chat in each breakout group so that you have that as a reference.
Oh, thank you.
Yeah. So welcome back, everybody. I was popping into the groups and I heard some great discussions, and I'm sorry I couldn't give you more time to chat, but we only have a few minutes left. And I really wanted to get both groups to give a chance to just do a quick share of some of the things that they were talking about so that we can all hear from it. So if I could have someone from the, well, really anybody, either group is just fine. I'm gonna let you, you should have the ability to unmute yourself. So feel free to just pop on and tell me what you were thinking about. And I know you all had interesting conversations because I was in some of them, so.
I will elect Carolina to represent our group.
Great. We clearly thought that there were a lot of questions that needed to be considered, and the checklist is helpful for sort of keeping track of all of those pieces. There was a lot of obviously wondering about the consent in the first place, but then we talked a lot about the issue of sort of selection bias, who does and doesn't have access to this app in the first place, and then how would they use it if they didn't know that their data was being used this way. We talked a little bit about trying to ensure fairness in the modeling process to make sure that whatever credits are being distributed equitably, regardless of the fact that different groups might have different levels of sort of baseline healthiness based on whatever the insurance company thought. And there was just a lot of discussion of when you have so many different data stakeholders, data coming from one place, going through insurance companies, going through a consultant, how do you sort of make sure that there's integrity to the sort of stewardship of the data and remembering who the stakeholders are across all of that. And sort of circled back around to actually what are the values of the project in the first place. And that wasn't really anything on the checklist exactly for that, but wanting to be sure that part of the process is actually articulating and making sure all the people involved in the project have a really clear common understanding of what's the value of this initiative and why are we doing it and how can we come back to that as we make decisions.
Interesting. I like that about there being actually a really important ethical component to just having that value statement and aligning on the value, right? So that makes sense, right? So it's not even about what are the principles we want going in, because I think through these discussions, we kind of get to do the principles on a more micro level, right? Of rather than just saying, oh, we care about fairness, actually getting into fairness and looking at how we'd measure that and what that means. But I like that, even just at a high level, what's the value there, right? That's great. Can I get a representative from the other group to share some thoughts? You can nominate your fellow group member.
Apparently it works.
I guess I'll talk a little bit because no one's saying anything, but I feel like we touched about a lot of the same things. I think we all kind of had an inherent problem with it from the get-go, just based on the data collection and how it subsets the population to maybe tend toward people who already have more money. I think we got caught up on that quite a bit, and also just the overall ethics of this. One of our team members pointed out, well, I think healthcare should be affordable to everyone, no matter how healthy you actually are. So I think we're really dwelling on the problems a lot. And then Emily suggested we think about some solutions about okay, despite all this, if this was your job, what do you do? And I think Allison mentioned kind of weighting, being able to kind of group similar, across the different demographics of the population you do have and how to group it that way. And I think you guys said something like that, have some sort of controls in place so you're not comparing an elderly person to a marathon runner in their 30s, and then another suggestion was, within one person's timeline, if this was over the course of time, how things change. and how that can be something that might be a good idea at first, but then, well, what if then they get injured? And so it looks like a big decline in physical activity, for example, like that could. So I don't know, we went back and forth, like these are some solutions, but then this is a problem with that solution too. So it kind of just shows the whole data ethics is a very important thing to think about quite a bit.
And it's hard, like that's
Yeah, it's hard.
kind of the point here as well, right? Where like you do come up with kind of a solution, but then you find the issues with that, right? Because there's not going to be a perfect solution that addresses all these things. And yes, this is a more extreme example that's in some ways a bit of a foil, right? It's really obvious that we're getting a super biased data set from only getting iPhone users that we know aren't representative, but we're going to have a bias in our data, right? And thinking about, like, there was a suggestion in one of the groups to try to reweight this, right? Maybe based on another data set to say, these are the demographics of iPhone owners, and so this is how we want to reweight that accordingly. Or thinking through, right, some of these things around what happens if you get injured, what happens if you get an illness, can we do this based on a baseline measure to try to capture that relative change, so we're not comparing across groups. Like, these are all things that are worth thinking about that are not, you know, just strictly better than the alternative. So I know that we are about out of time, so I just want to thank you all for joining these discussions and being such active participants. The last thing I'll leave you with is just this quote from Richard Feynman that says, "The first principle is that you must not fool yourself, and you are the easiest person to fool." So today, right, I haven't told you what the right answer is or what to do, but hopefully this has given you a way to try not to fool yourself and to be more intentional in the choices that you're making and in the consequences of those choices. So all the resources and more are up on dion.drivendata.org. So I encourage you to read more about this, pip install it, use it in your projects, and take this forward. Thanks, everyone.
Thank you.
That passes back off to Kristen.
Sounds great. Thanks for a great talk, Emily. It's a lot to think about. Definitely a lot of good questions. Now it's time for our break. So go ahead and get yourself a beverage and then meet back in the general channel at 4 o'clock for some closing remarks and then a description of the networking mixer.
Great, thanks.
Thank you.